This video is to solve the do now problems in the Algebra 2 Unit 4 last two pages, which are pages 33 and 34. So we're going to get started. I'd like you to try these on your own first, and then this is just going to be so you can check your answers when you're done. The first one, when x is in the exponent, this is going to be a log problem to solve for x. This log has a base of 7, and you're taking the log base 7 of 500, and that is equal to the exponent. So now what you're going to do is just take out your calculator, do log base 7 of 500, and the x value is 3.19, which matches up with option 1. The second equation is an exponential equation. X is up in the exponent, so you're going to use the log function. The base of this is 2. You're taking the log of 52, and that's going to be equal to x divided by 3, the exponent. Multiply both sides by 3 to get rid of that denominator, and in your calculator you can do 3 times log base 2 of 52 to get your answer. And the answer turns out to be 17.1, which is option 4. The next one, x is up in the exponent, so it is a log problem. The base of this is 5. Of 275 is equal to the exponent x minus 4. And to solve this equation, you're going to add 4 to both sides. So it's 4 plus log base 5 of 275, which is equal to x. The calculator says 4 plus log base 5 of 275 is equal to 7.489, which is about 7.49, option 4. The next one, growth of bacteria is modeled by the equation. Circle the equation. G is the final number of bacteria, and A is the initial number of bacteria, and T is time in hours. They want you to figure out how many hours, so you're going to solve for T. 4 bacteria is the initial value. 2,500 bacteria is the final number of bacteria. So you're going to just plug those two numbers into this equation and solve for T. 2,500 is equal to 4 times 2.7 to the 0.584 T. Divide both sides by 4. 2,500 divided by 4 is 625. This has an exponent that contains the variable, so it's going to be a log. The log's base is 2.7. It's the same as the base of the exponential. So log base of 2.7 of 625, 625 is equal to the 0.584 T, or 0.584 T. So to solve that for T, going to divide both sides by 0.584. So now we can get our calculator out. And in the numerator, it is going to be the log base 2.7 of 625, all divided by 0.584. And it looks like T is 11.09, and it wants you to round your answer to the nearest hour. So T is approximately equal to 11 hours. Number 2, the rate of growth of bacteria on a piece of moldy bread is represented by this equation. This should be a capital R, because R represents the amount of bacteria in millions. 24 is the initial amount of bacteria, because it says there were originally 24 million. Everything is done in millions in this problem. So how many minutes will it take for there to be triple that amount. Triple that amount, 24 million tripled. Everything is in millions, so it's just 24 times 3. Triple that amount is 72 million. But you just put a 72 in because everything is done in millions in this problem. So you're going to solve this for t by dividing both sides by 24. Do not multiply 24 times 2.5. That's wrong. 72 over 24 is 3, is equal to 2.5 to the power of t. This log has a base of 2.5 of 3.
Ryan Shoemaker, please dial 3704. Ryan Shoemaker, please dial 3704.
Sorry about that. Log base 2.5 of 3 is equal to 1.198. They want this rounded to the nearest tenth of a minute. So to the nearest tenth, it would be 1.2 minutes. On the back, Hannah is investing $3,850 at an annual rate of 6% compounded continuously. Well, the formula for compounded continuously is something you have to memorize. I'm not going to give you that on the test. You have to know that. A is the amount of money after a certain amount of time. P is the principal. That's how much she started with. She started with $3,850. The interest rate, 6%, is represented as a decimal by 0.06. And after 5 years, the time is equal to 5. So how much is the amount of money she's going to have? It's 3,850 times e to the power of 0.06 times the 5 years. And it looks like she'll have $5,196.96, but it says to the nearest dollar. So we're going to round this to the nearest dollar, $5,197. Determine how many years it will take for her investment to have a value of $10,000. Well, now the A value, the amount she's going to have after a certain amount of years, is $10,000. The principal is still $3,850 because that's what she started with. The interest rate is still 0.06, and you're going to have to solve this for t. So 10,000 is equal to 3,850 times e to the power 0.06 t. You're going to divide both sides by 3,850. 10,000 divided by 3,850 is a long decimal that I don't want to write. So I'm going to do a math option 1 frac, and I'm going to get this simplified down to 200 over 77 and use that value, just so I don't have to write so many numbers. 200 over 77 is that simplified. It's equal to e to the 0.06 t. The exponent has the variable. So this is a log problem, and this log has a base of e. The log base e of 200 over 77 is equal to 0.06 t, the exponent. So now you're going to just divide each side by 0.06 to get the t value. And in the calculator, instead of log base e, I'm going to type the ln button. Still going to use my fraction. So this is the ln of, I'm going to go up and grab the 200 over 77 divided by 0.06. And it looks like it's 15.908 years, and it says to the nearest year, rounded. So that would be 16 years approximately. The next problem is a radioactive iodine will decay according to this function, f of t. So f is the number of grams that will remain after t days. Now what we want to do is figure out 15% of the original mass. The original mass in any exponential function is this first number right here. The original mass is 80. And 15% of 80 is equal to 0.15 times 80. 0.15 times 80, 15% of the original mass is 12 grams. So we want to know how long it takes for it to decay down to 12 grams. 12 is the f of t value, so 12 is equal to 80 times 0.5 to the t over 60 from the original problem. We're going to divide both sides by 80. 12 over 80 magically turns into 0.15. 0.15 equals 0.5 to the power of t over 60. This is a log problem because the variable is in the exponent. This log has a base of 0.5 of 0.15, and that's equal to the exponent t over 60. Get rid of the 60 by multiplying both sides by 60. And t is equal to 60 times the log base 0.5 of 0.15. So 164 days. This is in terms of days. So approximately how many days? Approximately 164 days. Is this a half-life formula? The answer is yes. Why? Because this follows the half-life formula that we were working on in class, which says the population at any time t is equal to the initial population times 1/2 to the power of t over h. And this format follows the equation that we were given exactly. The initial value is 80. The base is 0.5, which is the same thing as 1/2. They're equal. And then t is time. In this example, it's in days, so the denominator is the h, the half-life value. So the half-life, which is equal to h, is equal to 60 days, because everything is in terms of days. Number 5, the Franklins inherited $3,500, and they're going to invest in their child's future college expenses. So they found an account that earns 8.25% interest compounded daily. And here's the formula that you have to memorize for the test. I gave it to you here, but you have to know it. So the A value is the amount they're going to have after a certain amount of time. P is the principal. They originally invested $3,500. The interest rate is 0.0825. Compounded daily means the N value. N is the number of times per year. There are 365 days in a year. And they want to know how much they're going to have after 5 years. So that means the time is equal to 5 years. And you're going to plug those 4 values into this to figure out how much the Franklins will have. 1 plus 0.0825 over 365, all raised up to the NT. 365 times t is 5. So we're going to just put that all in our calculator. 3,500 times 1 plus 0.0825 divided by 365 to the power of 365 times 5 years. And it looks like the Franklins will have $5,286.82. And in dollars, I'm assuming that they want it rounded to the nearest dollar, so that's approximately $5,287. And then the last problem, the Matthews family would like to invest $2,000 for their child's college expenses. They found an account that earns 6.75% interest compounded monthly. Now we have to determine the amount of time. We have to solve for t to the nearest year for the investment to double in value. And if the investment doubles in value, then the amount is double the original. The original is $2,000. The interest rate is 0.0675. Compounded monthly, the end value is 12 because it's 12 times a year. And the amount they're going to have is doubled the original, which is $4,000. You're going to use this formula that you'll have memorized for the test, which is 4,000 is equal to 2,000 times 1 plus 0.0675 over n is 12 to the 12t. Divide both sides by 2,000. 4,000 divided by 2,000 is 2. I'm going to put this number 1 plus 0.0675 over 12 in my calculator so I don't have to type so many numbers out. 0.0675 divided by 12. This is the base of my exponent. 1.005625. 1.005625. That is this number right here in parentheses. And you have to raise that number to the 12t power. So in order to solve this, you have to use logs. The exponent has the variable. This log has a base as the same base as this 1.005625 of 2 is equal to 12t, the exponent. So if you divide both sides by 12, you're going to get the t value. So I use my fraction button, my log button, and I'm going to just go up and grab that number to put it as my base of 2 divided by 12. And it looks like the time is 10.29 and they want it to the nearest year. So this to the nearest year, excuse me, is approximately 10 years. And that's it. Study hard for this test. Please review all of your notes. And I'll see you on Thursday.